Hello, today we discuss about hierarchical clustering. This method works by grouping data objects into a hierarchy or tree of clusters. It proceeds in two ways, agglomerative or divisive. The agglomerative approach, also called the bottom-up approach, starts with each object forming a separate group, while the divisive approach, also called the top-down, starts with all the objects in the same cluster. The agglomerative hierarchical clustering method uses a bottom-up strategy, as we said earlier. So each object forms its own cluster and distance matrix is computed. So here we see that the initial clustering is composed of all the items in their own cluster. So the cluster C1 composed of X1 and so on. Then this is the distance matrix which we compute. For the merging step, it finds the two clusters that are closest. This we are discussing under the nearest neighbor algorithm. We could also go for the farthest neighbor, which we will discuss in a future video. So we find two clusters Ci, Cj belonging to C, which are closest to each other, and we combine them. So Ci union Cj becomes Cij. This is the naming for convenience sake, and to keep track of which clusters we are merging. So iteratively, it merges clusters into larger and larger clusters, updating the clustering. See, the clustering is updated. From the present clustering, we remove the two individual clusters and add the new formed one. We also update the distance matrix, and this continues until either the one cluster is obtained or a defined number of clusters which was given as your target is obtained. In fact, there can be other stopping criteria which we would discuss in future videos. So we take an example which has just 5 points. As we can see, the 5 points and their coordinates, 2D example. So the initial clustering, see C1 is equal to X1, we have 5 clusters. In the initial clustering, we have all the 5 points individually in their cluster. So this is the distance matrix computed by Euclidean distance measure. So we see that the closest clusters are C1 and C2. See this one, C1 and C2. So 1 is the shortest distance in this entire matrix. So we say that we can merge C1 and C2. So see here, C1 and C2 have been merged in the cluster which we rename or name as C12. So the new clustering is composed of 4 clusters now. C12 includes X1, X2, while C3 is individual data, C4 and C5. See, we can see here 1 cluster, 2, 3 and 4. So again we compute the distance matrix. Here we have given the column labels for ease of understanding. The first one is our merged cluster, and then the remaining 3 data points which are individually in the clusters. Now we see that the shortest distance, we have 2 of them, but we can take any for our merging. So we are taking C3 and this will correspond to C4. So the closest clusters are C3 and C4, and so we would decide to merge these two. So we see here they are merged. So we have C12, we have C34 and we have X5. Now we again compute the distance matrix. See, we have explicitly mentioned the cluster names. And now 1.4 is the smallest one, which is from C34 to C5. So merge these two to obtain C345. So we can see now we have 2 clusters. We have C12 and C345, which comprises of 3 data points. C12 has 2 data points. Now again compute the distance matrix between these 2 clusters C12 and C345. So we have this value. This is only one last merging. So we obtain 1 cluster, the big one, which contains all the data points which were there in our data set. Now we talk about dendrogram, which is a tree structure commonly used to represent the process of hierarchical clustering. See, the first stage where we have 5 data points. So these are the data points, and this is the tree which we are growing starting from individual clusters. So 5 clusters, we have 5 branches. Next, we have 4 clusters. We have merged x1, x2. So this is the merging part. We can see this single branch coming from these two x1, x2 branches. So at this point, we again have 1, 2, 3, 4. So when you slice the dendrogram at any level of clustering, you can get the number of clusters. So in the beginning, there were 5. Now the dendrogram has grown down. We'll see how downwards. We'll see how it is doing. So here we have 3 clusters, then the 4 clusters. See, still the 5th one hasn't come where we have a single one. So 5, 4, 3, 2. See. So the first point where we had 5 clusters and then we combine the closest ones to get 4 clusters, 1 less. Then we again combine the next 2 closest ones and we get 3 clusters. See, again we can see the branches, 3 branches here. Then we further combine the C34 with X5 to get now 2 remaining clusters. So we have this branches, 2 branches. The entire agglomerative clustering process, we can see here 5 points, then 5 points, 5 clusters. Now 4 clusters, 2 in 1 cluster while 3 are individual. Now we have 3 clusters, C12, C34 and X5. Here we have 2 clusters, C12 and C345. Then we have a single cluster and the corresponding dendrogram. So see, if we see here at this point, see if we could slice it here, we get 5 clusters, which is this. Then if we slice it here, then we get 4 clusters, 1, 2, 3, 4. Next, I choose to slice it here. And what do I get? 3 clusters, which is this C12, C34 and X5. This is C12, C34 and X5. And at this point of slicing, we get how many branches? 2 branches. So one is this C12, which is this one, C12. And what is this branch corresponding to? It is corresponding to the 3, 4, 5, which is this one. This one, sorry. So 2, and finally we have this single branch, which means we have a single cluster C1, 2, 3, 4, 5. So the dendrogram gives you a clear picture of how the clustering has proceeds and which data points join one after another. And at any time, if you slice the dendrogram, you get the number of existing clusters at that point. So if we had this restriction of k equal to 3 for this data set, then this is our point. We would have stopped at this point. So we would have C12, C34 and X5 alone. This is the point. If we wanted 4 clusters, we would stop one step earlier, closer to the individual points, C12 and X3, X4, X5 alone. And finally, similarly, 2 clusters or 1 cluster. So the dendrogram gives you a very good visualization as to how the data points are joining. So I hope this has made you more aware about the agglomerative hierarchical clustering process. We will also further look into more stopping criteria and other distance measures for performing this agglomerative hierarchical clustering. So thank you. Thanks for watching.